Hi everyone, my name is Haiyi Zhu. I am an assistant professor in the Human Computer Interaction Institute at CMU. It is my pleasure to speak here today. Today I'm going to talk about bridging AI and HCI, incorporating human values into the development of AI technologies. As we have been seeing in the past few years, AI technologies have changed how we connect, communicate, exchange, and work with each other. These technologies are impacting our groups, communities, organizations in important and complex ways. At a high level, I do research in human-computer interaction, and I study how the technologies and groups, communities, organizations, market, and our societies are co-evolving and transforming each other in the process, and how can we design AI technologies to better serve our groups, communities, and our society. So AI systems, particularly we have been seeing they are making important social decisions or assist humans to make such decisions. For example, these tools and systems have been used to evaluate the risk levels of offenders, and they have been used to predict the risk of severe child maltreatment and help social workers to make decisions on whether they should investigate the cases or not. And these tools are also being used to filter and rank the job applications. And it has been estimated that over 90% of the large companies use these intelligent application tracking systems to automatically filter and rank these job applications. However, technically solid AI tools and algorithms can still fail when they are not aligned with human, community, and societal values. For example, the AI tools might have unintended biases and disparities that can harm the already vulnerable population in the society. For example, study has been shown that the risk assessment tools that have been used to automatically assess the risk level of defendants and help judges make decisions, and they have racial biases, and these algorithms can substantially have a higher error rate for African American defenders compared to the white American defendants. Another study shows that the Google Ads can also display racial and gender disparity, and the Google Ads often display the more high-paying jobs for male users than for female users. And when we open newspapers, like every day, we have been seeing stories about how some of the innovative AI technologies and tools might have the potential harms that can impact our lives and our society. So for example, Microsoft released their chatbot called Tay in 2016. And how this chatbot was designed in a way that they can learn and copy from the human Twitter users, and turned out that this chatbot becomes a racist in less than a day. This is another example Amazon trying to introduce and pushes their facial recognition tools and systems to police. However, it received a lot of pushback from people, from the critics, from community members, and who see surveillance risks. In my research, I want to study how can we design, deploy, and evaluate innovative AI tools in a way that can better incorporate community values, support members in the communities, and improve the overall community well-being. And my research has sponsored by various National Science Foundation grants. And specifically, I do research in multiple real-world domains. For example, I work on AI-supported online content moderations in the context of the Wikipedia community. Wikipedia, as we know, is the largest online and open encyclopedia. And in the recent years, Wikipedia has been facing significant challenges in maintaining the high quality of its content. And in today's talk, actually, I'm going to share some of our results on how we help Wikipedia community build a better quality prediction systems and tools to help Wikipedia editors to better moderate the content. I also work on peer-to-peer mental health support communities. And people with mental health problems are now increasingly turning to online peer support communities for help instead of professional services because these peer support services is much cheaper and more accessible. I work with one of the largest online mental health community called Seven Cups to understand people's experience in these online peer mental health support communities, and help design various AI tools and systems to create a better peer support environment. I also work on AI-supported child protection. If time allows, I will also share one of our recent work in the space of AI-supported child protection. And we have been working with Allegheny County to redesign their algorithmic screening tool to aid the call screeners in making recommendations regarding the further investigation. I also studied gig work, gig platforms, and the whole gig economy systems with the goal of designing the AI tools to empower and enhance the gig workers. So in today's talk, I'm going to talk about primarily introduce our work in the context of content moderation and child protection. I will start with the AI-supported content moderation project. A bit more background, and as I mentioned, so we primarily work in the context of a Wikipedia community, which is the largest online open encyclopedia in human history. And as we know, it is created and maintained by hundreds of thousands of volunteer editors all over the world. And in Wikipedia, and actually in English Wikipedia alone, it receives like a lot of edits every day. For example, the English Wikipedia receives about 160,000 edits by various groups of editors. And these edits actually show up on Wikipedia Live without review. So the quality control is one of the major tasks and faced by the Wikipedia community. Basically, they need to review these like edits and make decision on whether they should keep these edits on Wikipedia or they should revert this edit and remove the edit and revert back to the previous version. And to help make this content moderation process more efficiently, and the Wikipedia community have developed this AI-based tool called Objective Revision Evaluation System, ORES. We often call it ORES. And it is a machine learning-based quality prediction system that has been used to generate these predictions on the quality of edits. For example, whether this edit is damaging or not, whether this edit is a good faith edit or not. And later they also created different models that can also use to predict the draft or the article quality. And ORES has been deployed in 44 Wikipedia language communities, including some of the largest language communities like the English Wikipedia, German Wikipedia, and also some like relatively smaller language community like the Dutch community. And the ORES also provides like a prediction that has been incorporated in more than 30 different applications, including the recent changes on the Wikipedia interface and Huggle, which is a content moderation tool used by many experienced content reviewers. So our goal is to see how we can better design the ORES system and work with the Wikipedia community to make sure that these ORES systems are aligned with the community values. So our approach at a high level is called the value-sensitive algorithm design. And the idea is like we want to achieve these goals by with these 3 steps. And the first step is to understand the stakeholder values. And the second step is to explain the value trade-offs and tensions. Because yeah, if there is no value trade-off tension, then it's good that we should implement and trying to optimize all the values. However, oftentimes these important community values are actually in tension. They are not compatible with each other. You have to make the trade-off decision. So the second step is to actually capture and explain these trade-offs. And the third step is to, like, once we make these trade-offs interpretable to people, and then we will allow the community members and engage community members in the negotiation of the value trade-off and make these important trade-off decisions. So in today's talk, the first part of my talk, I'm going to talk about our 3 studies conducted in the context of Wikipedia content moderation. The first study is about the understanding phase. So we want to understand our Wikipedia community community stakeholders' values for this quality prediction system. And that work was published at CHI 2020 and received an honorable mention. And the second study is to create the visualization systems to capture and explain the trade-off between the multiple community values. And that work was published at this 2021, was led by my student, Ethan Yan. And the third study is new work, which recently has been accepted by FACT 2022. And in the third study, we conducted community workshops and to engage community stakeholders in the discussion and negotiation of these trade-offs. So before I move on to talk about the details of the project, any questions? Or maybe I should leave time for the question at the end.
Yeah, I think it's fine to leave at the end, if that's
okay. Sounds good. Okay, sounds good. Okay, so now I'm going to talk about first study to understand the Wikipedia community values. What we did is we conducted interview studies with 16 participants from different Wikipedia stakeholder groups. And they include the ORS creator, like founder and creator, and the main contributor of the ORS system. And the tool developers who created moderation, who developed those moderation tools, and which rely on the output of the ORS prediction. And we also interviewed the Wikimedia product teams, and as we know, Wikimedia is the organization that operates the Wikipedia. And we also talked to the Wikimedia product team to get their opinions about tools related to ORS. And we also interviewed 7 Wikipedia editors and 2 researchers who do research related to Wikipedia and ORS. And we ask questions like what your role is like on Wikipedia and your experience related to ORS, their opinions, ideas, experience, and we want them to help us to co-imagine the futures for ORS. And we analyze all the interview transcript and using the grounded theory method approach. And we analyze and coded every line of the interview transcript and have immersive group meetings to cluster the codes and discuss and iterate on the themes. And as a result, 7 themes emerge, and they include 2 creator values and 5 convergent community values. And these, the most interesting part is these 5 convergent community values, which are effort reduction, and the community members want this ORS system to design a way to reduce the effort for, especially the maintenance effort for the Wikipedia editor community. And they also value the human authority, and they told us that they believe that our system should not be designed to replace the human decision. They should be used to augment the human decisions, and the human judgment should be the final call. And the workflow support is about they believe that the system should be designed in a way to support the different workflows that the editors and reviewers are using. And positive engagement is another very important value. They believe the system should design in a way that empowers the different groups of editors, a diverse group of editors, that better engage different groups of editors. And last but not least is community trust. They believe that the tool should be designed to enhance the trustworthiness of both the individual members and the community as a whole. I want to highlight these two values, and they are the effort reduction and positive engagement. And for the full list of the values, and feel free to read our paper, or I can answer questions at the end of the talk. So in terms of the effort reductions, and participants are saying that it's important to reduce the effort of the community maintenance. For example, one of the developers told us that if we can leverage the manpower that we do have with more automation, these people will have less backlog and can focus on other contributions. And in terms of positive engagement, and our participants and told us that it's important to encourage the positive engagement with diverse area groups. The reason is that, for example, one Wikipedia researcher told us that I think the article quality is driven to a large extent by the diversity of hundreds of users who contribute and edit the article. And another, one of the product team members of the Wikimedia Foundation also mentioned that the current ecosystem of Wikipedia limits diversity of the contributors. So the ecosystem needs to change in order to be more welcoming to certain kind of people. And they believe that authors should play a role in terms of these changes to make Wikipedia more welcoming. However, these values are actually sometimes have tensions. So when we just looking at these two values, effort reduction and positive engagement, we see that in order to better satisfy the effort reductions, we want to have these RA systems should have high overall accuracy, so they can accurately predict whether this edit is damaging or not, whether you should remove it or not. And it should also have low false negative, which means that we want to catch all the possible damaging edits. On the other hand, if we want to prioritize positive engagement with the diverse area groups, so we want to make sure that we want to have a low false positive. So we want to make sure not to falsely label any good edits, because every time if you label any good edits, and then the editors will feel discouraged. And also we want to have low disparity between the model performance on different edit groups, including the anonymous edit groups, newcomers, experienced editors, and also edit groups from different demographic groups, edits made by editor from different demographic groups. However, there's a lot of the literatures in fair machine learning and have been discussing the trade-off between, for example, the overall accuracy and the disparity. So if you want to reduce the disparity, sometimes the overall accuracy will also drop. And we also know that there is a trade-off between the false negative and false positive. And when you want to reduce the false negative, the false positive might increase, and vice versa. So because of these value trade-off that we have been observed from the discussion, and then we for second study, and in this second study, we're trying to create a visualization system to capture and explain the trade-offs and between these different important community values. So our design goal is create a set of visualization tools to help the application designers and the Wikipedia community members to better understand the inherent trade-offs in the Wikipedia RA system, and to understand how, for example, false positive, false negative, disparity over accuracy, how these different machine learning metrics, how these metrics even mean, how they impact the different stakeholder groups, and how they are actually aligned or not aligned with different community values. So we create this tool called Auris Explorer. And we use this iterative design process and start with initial research, ideation, and followed by design, prototyping, user testing, and the final refinement. And next, go ahead. Is that a question? Sorry. Okay. That's not a question. Okay, so this is what the visualization interface, the Auris Explorer, looks like. And we first have like, this is a landing page. And we show some basic information about Auris. And this interface provides the basic background information on how Auris works, and also with some present some necessary machine learning concepts, and in a language that we believe through the user testing, we found the lay people can also understand. And in this way, we want to make sure that our users will have the necessary knowledge to explore the visualization that comes next step. And one of the main interfaces is called the Threshold Explorer, because we, as we all know, threshold setting will determine some of the major important trade-off, especially between false positive and false negative. So if the threshold is set to 0.5, and any edits with scores above 0.5 will be predicted as damaging. And the goal of this interface is to allow users to play with the threshold setting and visualize the trade-offs that are associated with a particular setting. The third main interface is called the group disparity visualizer. And on this interface, it allows the developers and the community members to see and compare the model's performance on the different groups in terms of their accuracy, false positive, false negative, etc. So in the context of Wikipedia, so there are a lot of discussion related to whether the model is biased against anonymous editors, newcomers versus more experienced editors. So these are so that's why in these interfaces we primarily present the disparity across these editor groups. So for example, as you can see here on this particular interface, we show the group performance on the anonymous editors, and who are anonymous edits, which are made by the editors and just with the IP address, versus the performance on the edits that are made by registered Wikipedia accounts. And the last interface, main interface, is called Threshold Recommender. So we present an interface that can recommend the threshold based on the user's goals and preferences. And the users can decide on whether they want a more aggressive model that can catch more damaging edits, versus a more balanced model, which is trying to balance some of the trade-off, especially trade-off between false positive and false negative, or they want to have a more cautious model, trying to focus on that, not to falsely labeling a good edits. And we will recommend a different threshold, but all users can still make a small adjustment based on the recommendation. And we conducted a interview, a think-aloud study, actually to evaluate the effectiveness of our tool. And our user study involved 10 participants and 5 participants from Wikipedia, and they are editors and tool user, these content moderation tool users, also developers and researchers. And we also interviewed 5 participants outside Wikipedia, and many of them are these user experience designer from companies like Spotify, Facebook, Amazon. So the idea is we want to see whether this design concept actually could generalize beyond the Wikipedia context. And what we found is that the ORIS Explorer really improved the participants' understanding of these trade-offs in setting like different ORIS model threshold, and this ORIS Explorer can also help them to understand the associated impact. One interesting finding is that although the group disparity visualizer and help service the ORIS model's performance disparity in the different other groups, most participants still accept the disparity as a natural occurrence and were not concerned about the fairness implications in the system. So we find that this especially interesting because because our Wikipedia participants also think so. So I think it will be interesting potentially to follow up to understand, whether to one potential explanation is that a lot of our participants, they are experienced Wikipedia editors, so they might think that they are also they themselves are experienced editors. So when they see that they are this model actually work favorably to them, and they might see it as appropriate. So it will be interesting potentially to have a broader engagement with more Wikipedia members, and then to engage them in these conversations. So maybe the results will be different. And that's partly what we did in the third study, is to conduct the community stakeholders that allow more like a broader community members to engage them in the discussion and the negotiation of the trade-offs. So in this work, we conducted community deliberation workshop and also created some visualizations to help facilitate these deliberation workshop. The goal is to explain the tension of the to the community members and resolve the tension between the community goals in the oral systems using the deliberation. And we conduct these workshops in two Wikipedia communities, the Dutch community and the English community. And this is our deliberation protocol. And we start with a pre-survey and ask participants to fill out a few simple survey questions and to understand their roles in Wikipedia, their prior relationship with ORIS, and their perceptions of ORIS. And then we ask our participants to use the ORIS Explorer interface to explore the ORIS model and the trade-offs. And also we also adapted the interfaces, and they can create a model card, select the model and create a model card. And in the next few slides, I will show what the interface looks like. And after the exploration, we started the group discussion, and we gave participants 40 minutes, and they can discuss the trade-off, the implications, the impact on different stakeholder groups, and ask them to write a proposal and to pick a model together. And at the end, we ask people to complete a post-survey. And this is the interface we show to our workshop participants. The main Explorer interfaces still remain the same, but we add these additional functions that allow people, once they pick a threshold, they can generate a model card, and which includes some key metrics and informations that actually summarize the performance of these models. We also have interface allow our participant to generate some explanation, like a rationale why they believe that this model is producing the best outcome and should recommend to the community to use. So each participant conducts this activity individually. And after they finish the activity, and we ask our participants to have a group discussion, and they are discussing, and they are for example, they are, what should be the definition of good outcomes for Wikipedia? What are the pros and cons of the different models that's selected by different individual members? And then we ask them to discuss, if you have to pick a model, what model you should pick. And after the group discussion, we ask our participants to write a group proposal about their collectively chosen model. And we ask them to write about their rationale, share their reasons. And first of all, we ask them to think about, is there any high-level principle values that our developers should consider to better benefit the English or the Dutch Wikipedia community. So in the interest of time, I'm not going to talk about too much detail about workshop, but here are some high-level summary of the findings. So we conducted four workshops in total, two in Wikipedia, two in English Wikipedia, two in the Dutch communities, and these workshops actually demonstrate the initial effectiveness of our approach, and our participants were really engaged, and they had really productive discussions about like what model their communities should use. And we also find some like interesting difference between the English Wikipedia community, which are a larger community, compared to the Dutch community, which is a much smaller community. And meanwhile, we also found some challenges for these community-centered deliberation-driven approaches for the trade-off decision making. So what we found is like, for example, there is like time and resource constraints, and which is consistent with some of the findings from the participatory design, and these deliberation workshops is indeed very time and resource consuming, although initially and many members are interested in participating, but they cannot find but because this workshop is time consuming, and sometimes they like some participants basically they drop out and didn't finish the workshop. We also find that technical literacy is still preventing some of the participants to engage in the discussion, although we had our tool and model cards and this ORS Explorer already like help lower the barrier for people to participate in some of the discussion. However, we still think that some of the tech literacy still prevents certain participants in fully engaging in these discussion. Also, there is issue with infrastructure, and in order to conduct this synchronous workshop, and we need to some basic infrastructure and like this Zoom or this video conferencing infrastructures, but these infrastructures can sometimes still cause some issues, so which leads us to considering other asynchronous maybe decision making protocols or solutions might be an alternative approaches in future. And to summarize, across these three studies, we believe that this work, sorry for the typo, this work contributes to a broader understanding of the human values related to the AI-supported governance in the online community, and also identify trade-offs between these values. And we also designed novel approaches like visualization, deliberation workshops that can facilitate greater community control and agency in the AI design. And together, the work demonstrates the general methods of community-driven AI design by soliciting community values and engaging community members in the trade-off decision-making. And we believe our work has a direct implications on the improvement of Wikipedia's oral system, as well as a broader implication on the design of content moderation systems for other online space. So the first set of work sort of uses value-sensitive algorithm design approaches, which is a top-down approach. We want to understand these values and then see how these values can help drive the design, help making these important decisions. And in the next part, and I want to talk about our recent work using a different approach. It's more like a bottom-up approach. So this is really inspired by the one of the HCI sort of principle, which is a very important famous quote about deep insights come from the field. And a lot of HCI methods focusing on the import of the context, and focusing on like you want to go to the user and watch them do the activities you care about, and talk with them about what they are doing right then. So by just working with these frontline workers who work with the AI system, and we might identify like what are the better ways to design these tools. So we use these approaches in a different domain and in the context of child welfare. And a little bit background, in the United States, the child protective systems actually receive over 4 million referrals every year, which involve over 7 million children. And the call screeners and who are social workers, and they actually decide like whether to screen these incoming referral cases and for investigation, or they should screen out these referral cases and not to open up like more like new investigations. And in the Allegheny County, it's a county where Pittsburgh is, and they during this child maltreatment screening process, they use this AI tool called the Allegheny Family Screening Tool, AFST. And this tool is designed to assist the call screeners and supervisors screening decisions. And this is what the interface look like. So when there is an incoming referral calls, and the tool will automatically collect the information and then generate a score from 1 to 20, and basically categorize these cases into like low risk, medium risk, and high risks. Our research question is, how do the frontline workers decide when, whether, and how much to rely upon these algorithmic recommendations, and what limitations and future design opportunities do the worker perceive for the FST and future these algorithmic decision support tools? And what we did is we conducted contextual inquiry and semi-structured interviews, and we did 2 field visits and over the course of the 2 weeks, and to observe and how these co-workers actually use these tools in their daily work. And we generated 92 pages of observation notes, 37.5 hours of observations and interviews, and 9.5 hours of audio recordings, which involves 9 call screeners and 4 supervisors. And this is a set of highlights of our finding. What we found is that the workers' reliance on our FST model is guided by the rich contextual information beyond what the model can provide and have access to. And their reliance also is guided and influenced by the perceived model capabilities and limitations, and also influenced by the organizational pressure and incentives. And finally, we also find that there is a misalignment between the algorithmic predictions and the worker decision targets. And next, I will walk through these main findings. So first, we found that these workers, their knowledge, their reliance is guided by the knowledge of their rich contextual information. So, for example, what we found that is a lot of these contextual information is not actually captured by the administrative data that the model uses. And what we found is that the workers often compensated for gaps and the limitations in the model's risk scores using their own understanding of the case-specific context from the allegations. And for example, the workers will consider potential cultural misunderstanding or the different motives of the callers to inform their decisions around like overriding the algorithmic recommendation, especially overriding high-risk scores. We also find that the beliefs about these FST's capabilities and limitations are also influence how they use these tools. And unfortunately, the workers are intentionally given minimal information about the FST, in part because of the concerns about potential maybe gaming the system. And however, these workers improvised strategies to learn about the model on their own through their day-to-day uses, and they even have these guessing games, and they were trying to guess what the outputs are, and they even sometimes play these games with other workers, with each other. And we found that workers formed sophisticated but imperfect beliefs about these model behaviors, and which they used to calibrate their reliance on the tools. And given the influence of these workers that like informal beliefs had on their tools, it's actually unclear whether the agency's goal for limiting the model transparency were actually achieved. And while we also found that the organizational pressure and incentives around the use of these tools also influence the people's use. In the prior literature, often talk about the human reliance on these AI tools are discussed as a matter of like whether this individual trusts this AI or not. However, what we found is that in our work, we found that these worker reliance was shaped by their perception of the organizational incentives and the pressures, and the child welfare agency sometimes use how these workers interact with FST and how they are like reliance on FST as a performance measures, and they sometimes often like track how often the social workers actually override the FS decision, and these like activities or these use of these performance measures actually impact the workers' reliance on FST. So sometimes they feel like they have these received these kind of implicit pressures to rely on the FST and agree with FST. And finally, what we found is that workers told us that there is some misalignment. They believe there is some misalignment between the algorithms' predictions and their own decision-making objective. So the workers are aware that these FST were designed to predict like a long-term risk. And specifically, they are used to predict, they're designed to predict re-referral in 6 months, and also home removal in 6 months, re-referral maybe in 2 years. Oh, sorry about the time range, maybe that's wrong. But yeah, these tools were designed in a way to predict some long-term risk and rely on some indirect proxies like a re-referral and home removal. However, the social workers, they told us that their decisions were based on the immediate safety concern. They were like, no matter what the history has been telling us, I want to see where this particular kid, in this case, are they experience some immediate safety concern. They perceive that there is some misalignment between the prediction targets of the tool and their own goals, and which influence their reliance on the tools. So some workers also expressed that they are uncertain about whether and how to integrate these FST's judgment into their own decision making, given this misalignment. And these results actually help inform some really interesting design opportunities and design applications. Specifically, the workers have incomplete mental models and have really limited and imperfect understanding of how this algorithm works. And as a result, they have sometimes influence their reliance on these tools. So as a result, we propose that we might want to develop a better training to better help the workers to better understand and build a more accurate mental models about FST. And also want to create interfaces to support workers and their reliances in real time in practice. And our results also show that there is a misalignment between the worker goals and predicted targets, which indicate that maybe we should develop a better model that can better align the predictive targets with the stakeholder value and worker goals. And our results also suggest that there are organizational structure and pressures that inform the usage of the tools, which suggests that we should design a better organization structure and environment and context that can, and with more appropriate performance measures and incentive structures to ensure the like a better use of these tools. And to summarize the study, what we did is a series interview and contextual inquiries, and in the context of child welfare with the child mailroom hotline screening workers. The goal is to understand their current practice and challenges in working with AI-based decision support tools. And we identified these training level, interface level, and model level, as well as the organization level design opportunities to better support more effective human AI collaborative decision making in high-stake social contexts. So a few like big pictures. So overall, we believe that AI can provide new ways of approaching problems and meaningfully improve people's lives. However, it is critical to ensure that the AI technologies, once it's introduced in the complicated social context, can actually achieve the designed outcome. So what we have been doing is trying to work closely with the multiple online and the offline communities to understand their problems, understand how they use this tool, to understand their goals and the values, and to help address their problems, to develop tools to better help them. And we want to, on the top of it, to to synthesize all our findings across multiple domains to our long-term goal is to create a generalizable framework and toolkits and to support and facilitate a community-centered AI design in different domains. So I think that's it for today's talk. Sorry, it might take long, or it take 50 minutes. And I want to thank my students, collaborators, and our community partners. And I'm happy to take any question.